All right, hello, biomechanists. It's Dr. F. So I was thinking about maybe doing a live class, like synchronous, where we could do some of the MATLAB programming. But then we actually got some like really crazy weather here, and I think some more is coming our way. A bunch of trees blew down. They like basically blocked the highway between my house and West Point too. So I got a little nervous. And actually, another student said they don't have power right now. Not sure if they could see it. So I wanted to make sure that I got it done. So I'm going to do it now. Do a video, post the video, and then if you have questions, you can ask me during the class time or whenever, right? If you need AI, just schedule with me. I haven't had anybody really schedule much AI with me, but I'm around. I'm here. Not going anywhere. So if you have any questions, just let me know. I know the MATLAB programming is a challenge for some. As Sam said in the comments, it's hard to do it with groups, right? I get it. It's hard. But the only way you're really going to learn is like to take a real problem that you have to solve and just spend a little time messing around with it. So if you have questions, let me know, and then you can share your screen and I can help walk you through it. Kind of like what I'm doing today, but either one-on-one or with your whole group so you can all understand it, right? Again, you just got to get over that hump and then it's really helpful. A couple admin notes. I posted some admin slides with recordings. Please watch those. Talks about what does the rest of the semester look like, and a lot of it's sort of working on your own. There aren't too many other guided lectures outside of this one. It's a couple of the problems. It's a couple of the drops, so you can schedule your EDPs, your IPRs with me. There's some time to work on problems and work on this project. For one thing in particular, the JMR, I dropped the discussion for the last JMR just because it's kind of hard to get everybody to set up these meetings, and you're going to have to do a lot of it for your final project. So I figured let's just do that individual only, submit your 2-page summary on Teams, and that way we can just sort of focus on the final project, which is a big portion of your grade, right? It's more than a quarter of your grade. So I want you to give it as much time as you can reasonably. Again, I realize it's a tough situation, so don't kill yourself, but keep it, give it the sort of attention it deserves and start early, right? If you start early, then you can ask me questions, then you can not get stuck on like some little thing for like a day, right? Just let me know, and then we can keep things moving. What were my other notes that I wanted to say? Oh, so I forgot to mention, I canceled the t-shirt orders. I know I extended it for a week. We had about 10 people who signed up, but I also wasn't sure like how I was going to get them to you if we don't come back this semester. And then once they pushed it, I just said we're going to just cancel the order, and I'll probably open it up at a later date. So, whenever everything settles down and we're all back at West Point, I'll send out the list or a link again to anybody who wants it, and we can find ways to sort of ship them to you if you want, if you're graduating or whatever. But I figured for people who bought it, they might not want to now if they know they're not going to get it for, I don't know, 5 months or so. Oh, group signups. So not everybody signed up for a team for the final project. So get on there. Go to the channel that's Z underscore, so it should be the last channel, final EDP, go to files, go to group signups. There you can type in the people, up to 3 people who are in your group. It's also when you're going to put your times for each of your IPRs. So 11 people who haven't signed up, sign up. You need a group. Get a group. All right. I think that's it for the admin. Again, watch the other slide. That wasn't everything, so make sure you go check that out. But what I want to do now is I want to show you what the MATLAB shell is. So I gave you a shell. I'm going to walk through a couple parts of that shell, which sort of just helps you load in the data. Then we'll work on a few portions of it, like how I think about sort of solving these problems in MATLAB, just from like a sort of programming perspective, or how I walk through it to sort of help you do all the things you need to do on your final project. So maybe I should share. I've already shared the EDP. I spent a lot of time going over that EDP. So if you haven't watched that, go back and watch that one. And let's just get right into some MATLAB now. All right, so you should be able to see my screen, right? So this is the shell. This is our last one. We can close that. So this is our ground reaction force EDP2 shell blank, right? It's not completely blank, but it'll help you work through some of the problems, right? So created by me, help you get started. The first thing we're going to do is pull in the data, and actually I'm going to clear my workspace because I was just working on stuff. So if I clear all, close all CLC, closes anything that's open, you can see the workspace here is now empty. So what I want to do now is I want to load in one of the files, right? So we need to enter in one of our treadmill data files. So this function, UI get file, is a user interface get file. MATLAB made this for you, right? If you don't really know how it works, or you want to like mess with a file that MATLAB has, but you don't know what to do, you can either type doc and then the name of the file, UI get file, like that. So what this is going to do is it opens up the help window with documentation. I'm not sure if you can see this because I don't know what you're exactly sharing, what's exactly being shared, but hopefully you can see it. The documentation popped up and it gives you all the details about this function and how it works, right? So if you get lost, that's another way to do it. I think also help UI get file, or whatever function you have, you hit help. Yeah, then it just gives you a lot of the details you need right here. So you can definitely see this, right? So sort of what are the inputs, what are the outputs, all that jazz. Right, so for this one in particular, I already figured it out. So it's going to be UI get file. It's going to look for only .mat files. So that's MATLAB data files. It's going to say enter treadmill movement data, just to like give the user a heads up, and it's going to give you the trial name and the data path. So if I run this, again, by right-clicking, hitting evaluate selection, or just hitting F9, it's going to pop up. Again, hopefully you can see this. And now I'm going to go and you can select any file you want, right? So we can go to, well, where are my files saved? If I go to EDP2, XE310, all the data, this is all the data that you should be able to download from Teams. So now let's pick one, right? So let's pick walking loaded, Team 99. So this is my data, GF, male, 33 is how old I was when I did it. 88 kilograms, probably a little more than that now after this quarantine, but who's counting? All right, so you can see, what did it give us? It gave us a variable called trial name. So that's just the name of the file. And then data path is where it's saved on my computer. So on my computer, it's in the C drive, users, Gregory Freisinger, West Point Castle, blah, 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 right? So this is where it's saved. So what this next one does is current directory. So it brings the current directory to the data path. So if you weren't in the current folder, it'll bring you there, okay? Which is just helpful for loading the files. And then what I want to do is I'm going to load, again, the full file. So full file, if I just run this part and hit F9, right? But that is just combined the name of the file and also where it is located, right? So this is the location, and there's the name. So now if I load it, what's going to happen? It's going to load that mat file. So if you look at the workspace over here, the workspace is going to add whatever was in that mat file. And this is probably a good point to take a break and like say, well, where did we get the mat file, right? So this all these .mat files here, where do they come from? Well, this is your experimental data, right? When we went to the biomechanics lab, we tested people multiple times. These on the side here are all of the files that we basically pulled from that Vicon program. So we saved the data in Vicon. We said, take everything you have, put it into this mat file, which is just a MATLAB, basically repository. So then when we load it, boom, right? Look at all this. So you can see now there's tons of stuff. So this is everything that Vicon had in it. Everything it had is now over here. Okay. So for this project, we don't really need everything, right? What do we actually need for this project? We're going to be analyzing the ground reaction forces. So where are the ground reaction forces here? Well, if you never used it before, you don't really know, right? Like, I don't see anything that says ground reaction forces. I see a FP, maybe that's force plate left. It's just a -1. That's not very helpful. There's marker IDs, there's N labels, right? So this is where it can get a little confusing if you don't know what it's saved in the other file, right? So that's where I'm going to help you sort of narrow things down. So I'm going to clear all the variables except data path trial name, which is what we saved before, and then analog data and analog labels. So now all that's left are these 4 things. And if we click on analog labels here, these are all of the analog data that was collected during our trial. So these are the labels and then analog data. These are all the data streams. So you can see there's 19 different cells where the first cell is force plate 1, forces in the X direction. The second cell is force plate 1, forces in the Y, force plate 1, forces in the Z. So here's your X, Y, and Z components. These are your X, Y, and Z moments. This is your center of pressure. And then here we start to get to force plate 2, right? Force plate 2, Fx, Fy, Fc. Moments about each of those. Center of pressure about each of those. And then 19 is this force plate 3 underscore event trigger. So we can, event trigger, which we'll talk a little bit more about. If you watched my other video, is that's the button. So that's what we used. We pressed that button when the left foot was on the ground during running. All right. So now we know the labels for each. And if I go in here, right, each of these are 6,000 frames long because we collected 5 seconds of data and we were collecting that at 1,200 hertz. So every second we got 1,200 data points over 6 seconds. And there they are, right? These are all the data points that would have happened for forces in the X direction over the length of the trial. You can see it was 0 for a while, right? There's 0 again. Right, so that's all of our data for FP1Z, and you have that for XYZ and everything you need. All right, so now our workspace is a little bit cleaner. We don't have as much stuff going on. We can start to think about how do we analyze it? What do we need to do? So one thing I'm going to do here is I'm just going to say, well, what subject is this, right? Like I loaded in, I have this Team 99 GF, right? But what's my subject name? So if I take the trial name and just look at the 5th and 6th characters, right? Then I know, well, this is subject 99, right? So you can say 1, 2, 3, 4, and that's 5 and 6. So this is just going to be an easy way to sort of keep track of which subject you're looking at. Because it'll be numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then obviously mine is 99. Okay. So here's a little bit more sort of cleaning of the data. So what I want to do is I want to actually filter some of this data because there can be noise, right? I guess we could try and plot some of it right now to see what it kind of looks like. But what you'll notice when we plot it is it looks like there's some noise in the data. So what's the best way to do this? I guess I could type it down here. So I want to plot, right? And let's say I want to plot forces in the Z, right? So we just looked at over here, analog labels, right? Here's my analog data 1, 1, right? So that's just all this data is analog data 1, 1. So if I want to plot that, I'd say plot analog data. We need to use the curly brackets because it's a cell. And if I plot this, what does it look like? Oh man, I really hope you can see this. This is going to be a real bummer if you can't see my figures. Let me unshare and try and share again. Oh wait, maybe if I make this a live script. What should I do? A live script? Is that easy to do? I can't remember how to change it. Publish view. Oh man, I bet you some of you know how to do it too because you went to that MATLAB tutorial thing. New live script. Can I just make this one a live script? All right, so I copied and pasted it here. Now I'm going to move this plot into this actual script. So I'm going to copy this. Let's say we're here now. We loaded it. We cleared it. Analog data. What happens now if I hit F9 here? Well, that's not helpful. Maybe I need to save it. Save. Let's save it as. Okay, so now that it's saved, what happens if I hit F9? It still pops up over here. Why isn't it over here? How about this? All right, so what I'm going to do actually right now is I'm going to stop this video. I'm going to take a look at it to see if you can actually see these figures when they pop up. If so, we'll go with that. If not, then I'm going to change it to do the live script, hopefully, so that we can see what's happening. Okay, but for now, right, where are we going to stop? We stopped right here. We pulled the data in. We're starting to separate it. I tried to plot analog data 1 to show you that it looks kind of noisy, and then we're going to do some filtering. All right, so I am going to click here. I'm going to stop recording.